Hey, this is Prof. Hamilton, ready to run through Chapter 3 with you. Let me go to the first page here. I'll start the show here, and again, I encourage you to print these out, 6 slides per page or so. I think there's about 33 slides in this set, although, well, the last 8 or so we won't cover that are on regression analysis. So this is really about elasticity, and we'll talk about what that means here. Essentially, it's looking at, well, if one thing changes, how does that affect something else? Doesn't sound too bad. So here's our learning objectives. Let me just add that number 6, again, we're not going to focus on. So I also teach the MBA business analytics class, typically in the summer, and so we'd cover regression, and some of you will have seen that already in a class, but it takes us a little bit too far out of the economics into statistics, so I'll just leave it at that. So again, yeah, this chapter is really about elasticity. You can almost, or you can substitute the word kind of flexibility or reaction, and it focuses on, as it says here, given the percentage change in one variable, we call it our input, how does that affect a second variable, our output, in percentage terms. So there are, so yeah, a general formula would be, if I redid this slide here, I would call this percentage change in input, and on top, percentage change in output. There are, again, I left this in here, but there's some calculus involved when we're talking about rates of change, but no need to take that in. In the chapter, you'll see some of that in I think the appendix, or one of these chapters anyway, where they get into more details. But again, this isn't a calculus class. It's managerial economics. So if that helps you a little bit, great. If you're not a calculus person, let it go. You're not at any big disadvantage, not a disadvantage at all, really. Okay. So elasticity, one thing you can tell us about is well, two things. Just qualitatively, do they move in the same direction? If the input increases, does the output also increase? Or do they move inversely? One goes up, the other one goes down. Secondly, what's the magnitude? So in particular, is there a big change? So a 1% change in the input changes the output by 5%, 5 times more? Or is it pretty small? A 10% change in the output only changes, excuse me, a 10% change in the input only changes the output by a little bit, 1%. Okay, just some made-up numbers. The most important one comes from the demand curve, and that is, again, the notation gets a little bit messy here. So elasticity and then the subscripts are the two variables with all kinds of notation. So the variable is x, quantity and price, and then the d is for, this is the demand curve. But really what we're looking at here, yeah, the percentage change in the price, we're considering that the input, something the manager can control. How, according to the demand curve, is that going to change output? So yeah, we're moving along a demand curve. Okay. Typically, we take the absolute value of the elasticity. If we didn't, it would almost always be negative because of the law of demand. If it's greater than 1, we have, at least on that part of the demand curve, it's elastic. If it's less than 1, it's inelastic. And if it's exactly 1, a 1% change in price changes quantity by 1% in the opposite direction, then it's unit or unitary elastic. So one way to solve this, sometimes we would have just a graph, other times we may have the line, the equation that gave us that line. So here we have, it's just stating this two different ways here, but we're going to look at 2 points. So the first one says if the price was 30, the quantity was 20, the revenue is 600. And I'll come to that in a minute while we're doing revenue. Okay. So the elasticity formula is, oops, jumping around here. Okay. Going between two different examples, is a given there. So it's going to be, at that point, is -2 times the price divided by the quantity of 20 is -3. So if we took the absolute value, it would be +3. But yes, it's elastic. Okay. For another point, if we looked at a price of 10, so revenue is 10 times 60, still 600. Using the elasticity formula, -2 times the price of 10 divided by the quantity of 60. Now it is a pretty small number, less than 1. So demand is inelastic on this portion of the curve. So even though we have a straight line, intuition may suggest that you'd always have the same elasticity, but in fact that's not true. Okay. So one way that's I think is really intuitive that can help is this revenue test. So revenue, recall, is price times quantity. So when we change price, we're also going to change quantity, and the question is, well, which one's changed more? Okay. So this is one of these things that they write both ways. It makes it a little hard, so I'll just go with a positive. A price increase leads to a decrease in total revenue when demand is elastic. Let me go to inelastic. I think that one's a little bit cleaner to think about. So if demand is inelastic, again, you can substitute in the word inflexible. So if people, it's a necessity in some respect, or could be, well, then a price increase leads to an increase in total revenue. Why? Because nothing changes. If a hospital raises the price on heart surgeries, well, you could say, well, there's insurance and other stuff involved, but even if there wasn't, it's a necessity. People are not going to try to meet their budget by saying, well, I can't pay an extra 10%. Quantity would change little or anything, if anything. When demand is unitary elastic, total revenue is maximized, and we'll see that here. Okay. So if demand is perfectly inelastic, it is vertical. That's just saying, yeah, at any price, whether it was down low at whatever this may be, $10 or $100, say for a textbook, if it's required. Of course, you could say, well, there would be a little bit of flexibility. You'd try to not use it maybe. Some people would skip it and just get the notes. Other people would share books. But so it's for something like a textbook, I would say we might think it might be highly inelastic. Probably more intuitive examples are things like medical needs, where again you pay the cost to save your daughter's life. Okay. Perfectly elastic is a little bit stranger in that, well, it's horizontal, which says if you try to go above or below the price, let's just stick with above, there's no demand for that. And this has to do with perfectly competitive markets, which we'll talk about in a later chapter. Okay. So 3 kind of general things that can affect elasticity. One is, what are the alternatives? So when the price goes up, are there many or a good alternative? Then people might quickly jump to that. How long? So in the short run, we might think a lot of times there's contracts or just practice. So if you go to the grocery store and something you like is more expensive than normal, milk say, you would still buy the milk. In the long run though, maybe you substitute out, you drink less milk, you find soy milk or which is even more expensive. But anyway, but yeah, over time, people have time to adjust to essentially find more consumption substitutes. And then part of this, and some of these kind of overlap a little bit, how much is it of a typical consumer's budget? Okay. So we might think, yes, if it was something like toothpicks, something trivial, or pens, people don't comparison shop to buy a pack of 5 pens. You know, it's, who knows, is it supposed to be $1 or $5, but probably not $25, right? So that can factor in as well. Here's a formula, and again, this we don't derive it, at least on this slide here. The book gives some more details, but this has to do with this idea of marginal or extra revenue, and we can find that quickly from two things really: the price that we're considering and the elasticity at that price. So most times in at least economic textbooks, we'll be looking at straight line demand curves, and there's a mathematical property that you can look at. I think the book gives maybe a little more of the derivation, but essentially this marginal revenue curve starts at the same vertical axis or vertical intercept and slopes down twice as quickly. Okay, a few other things from this graph here. So typically on the upper part of a demand curve, that is the northwest, tends to be elastic. There's a point where it's unit elastic, and then on the lower part it's inelastic. Okay. So that was all about own price elasticity. If the price of tuition raises at Asbury, how does that affect the enrollment at Asbury? Cross-price elasticity is just that. We're looking at how does the price of another product, a complement or a substitute, affect the quantity. So back to my college example, how does a change in the price at University of Kentucky affect the quantity or the enrollment at Asbury? Well, you say for many people it doesn't matter. You're out of state, or you want to go to Christian liberal arts college, and UK is not that. Okay, but for some people it was a potential school, and so if the price fell, we would say at UK, if the tuition got even cheaper, watch out, they'll get you on the room board though at UK. Then we would expect at least some students, and we could find what percentage would decide to go to UK. Okay. So yeah, if the price goes up of the alternative good, and the quantity also goes up, then the two goods are substitutes. If they move in opposite direction, so if the price of X goes up and Y goes down, then they are complements. So here's some examples. I will let you read through those. The homework repeats these in various contexts. Okay. There is a pretty interesting formula that, again, just the notation makes it look worse than it is, but this is, as it says here, looking at how, if you have two products, how does, what's the overall change in revenue from a price change in one of those. Okay. So here, change in R is the total company revenue. We have two products, X and Y, with their revenues. We have the elasticity, own price elasticity of good X, and then we have the cross price, or excuse me, the cross price elasticity, the price of X to the quantity of Y. So this works through an example here. again, the formulas, maybe you can kind of gain some intuition from it in terms of this impacts this times this, but to get the solution at a simplest level anyway is just plugging in the two revenues, the two elasticities, and coming up with an answer. So I think this is kind of a neat application. So we had own price elasticity, we had cross price elasticity, and now we come to income elasticity. So same ideas, we're changing, or maybe we're not changing, maybe the economy is doing well, so average incomes are rising. How is that going to impact our product? Well, typically we think that would be a good thing, and it is if our X is a normal good. As people get wealthier, they buy more X's. But there are some things that are inferior. I think we talked about this in an earlier chapter. It doesn't necessarily mean they are low quality, but in people's minds, as we get richer, we do drop out of, at least some people do. You don't go to McDonald's. If you have a little more money, you go to a nicer restaurant. Fazoli's, maybe. I don't know. I like both those. Or you don't, at some point you get a fancier car or a bigger house or use higher quality products. Okay. So again, here's an example here. I'll just leave that for you to review. There's other elasticities. Just, well, if what about marketing? If that changed, how would that affect our product? Most of the time we're going to have a linear demand equation, so there's no logs or any other thing that are jamming it up. First bad joke of the lecture here, okay? So yes, again, the notation, well, for some reason economists and others like to use Greek letters to signify, in this case, coefficients, but if you don't like that so much, you can look at the just the example here. So the nice thing, if you have an equation, and there'll be one or two examples in the homework, is you can just use the coefficient of x times the price of x divided by the quantity of x. Cross price elasticity is similar. We use the coefficient, but now the coefficient on the price of y, and then we use the price of y divided by the quantity of x. Okay. Income elasticity, you can see it here, same idea in spirit. We have a coefficient from the equation, we have the quantity, and then the income is m. So here again is an example. I think this makes it pretty clear at least how you find an answer, and as long as we trust the formulas, which we should, we get a quick solution. Okay. Sometimes we do have curved or nonlinear demand functions. A lot of times that gives us a little better sense of it fits reality a little bit better. Okay, so equations are never or rarely going to be perfect representations of reality, but again, this makes the equation look a little bit worse, I guess, unless you like natural logs. Okay. The nice thing here is now the coefficients from that equation are already the elasticity. So the coefficient on the price of x is its own price elasticity. The coefficient on log price of y is the cross price elasticity with x. And then income elasticity, so on and so forth. Okay. So here again is an example. I'll leave that for you to read through. One last point here. The chapter does spend some time talking about regression. As I said in my intro to this lecture, it's fine. I mean, if you want to read through this, you may gain, well, where do these equations come from? That's regression analysis. So it can be pretty involved for some technical reasons. One, you have to have data, and that's not always possible, or you have to run surveys, and it seems in some ways you can get some pretty good answers from simple regression, but in the real world there can be quite a few complications. So I've left the rest of the slides in here, but for our purposes, that is all you need to know to understand from this chapter, to do the homework, and be ready for the exam. So I'll be posting some of these homework solutions later this week, but give those a good college try.